What if the surgeon operating on your heart was never human? Right now, in labs across America and Asia, machines are being built that can cut, stitch, and heal with precision no human hand can match. This is not science fiction. This is the hospital of 2035, and it is already being built. Every single year, nearly 250 million major surgeries happen worldwide. Tens of thousands of patients die, not from disease, but from human error in the operating room, fatigue, trembling hands, distraction. But what if we could eliminate every single one of those mistakes? What if the surgeon never got tired? Imagine walking into a hospital where the hallways are silent, the machines are humming, and a robot is performing open-heart surgery with movements 10 times more precise than the finest human surgeon alive. No fear, no fatigue, no failure. Welcome to the future of medicine. Stay with us. This will change everything you believe. The race to build the robotic hospital of 2035 is already underway. Companies like Intuitive Surgical, Medtronic, CMR Surgical, and a wave of AI-powered startups are investing billions. Governments are funding it. Universities are designing it. And the blueprints for tomorrow's operating room look nothing like anything you have ever seen inside a hospital today. This matters not just to doctors or tech investors. It matters to every single person on this planet who will one day need surgery. That means you. That means your family. The robotic surgical revolution is the single biggest transformation in healthcare since the invention of antibiotics. And most people have absolutely no idea it is happening. Here is what is at stake. In the United States alone, surgical errors cost over $20 billion every year. Globally, preventable surgical deaths number in the hundreds of thousands. Robotic surgery is not just a cool technology. It is a life or death mission. And the Hospital of 2035 is designed to bring that number to zero. Let us go inside. Picture a massive facility, part hospital, part technology campus. Surgical robots are stationed in gleaming operating theaters lined with sensors. AI systems monitor every breath, every heartbeat, every drop of blood in real time. This is not a warehouse of machines. This is a living, thinking, breathing ecosystem built to save human lives. Before a single robot ever enters an operating room, it begins life as raw engineering. Titanium alloy arms, carbon fiber joints, micromotors capable of movements measured in fractions of a millimeter. Every component is manufactured to tolerances tighter than anything found in consumer technology. A robot surgeon's hands must be more precise than a Swiss watch every single time. The robotic arms you see in these surgical systems are marvels of mechanical engineering. Each arm contains dozens of individually controlled joints. They can rotate, bend, and pivot in ways a human wrist simply cannot. A human surgeon's hand has natural tremor, invisible to the eye but dangerous at the microscopic scale of delicate tissue. The robot has none. Inside the assembly facilities where these machines are born, human technicians work alongside robotic manufacturing systems. The irony is real. Robots are built by robots. Laser-guided assembly lines construct the micro-components. Clean rooms maintain air purity levels stricter than a semiconductor factory. Every bolt, every wire, every circuit board is tracked by serial number from birth to deployment. But here is where things get truly extraordinary. These surgical robots do not work alone. They are controlled by surgeons, but from a distance. A doctor sits at a haptic console, sometimes miles away, and their hand movements are translated in real time into robotic motion. The robot filters out human tremor. It scales movements down. Precision becomes absolute. This technology is called teleoperated robotic surgery, and it has already been performed across continents. Surgeons in New York have operated on patients in rural Africa. Doctors in Tokyo have guided robots in European hospitals. Distance is no longer a barrier to the world's best surgical expertise. Geography no longer decides who gets the best care. Think about that. Now add artificial intelligence into the equation. The AI systems inside the Hospital 2035 are not just assisting surgeons. They are learning from every single procedure ever performed. Every cut, every stitch, every complication, every success. The AI has studied millions of surgeries. It knows patterns no human brain could ever recognize, and it uses that knowledge in real time. Imagine a robotic system that can predict a complication before it happens. The AI detects a micro change in blood pressure, cross-references it with 10 million past cases, and alerts the surgical team 3 minutes before a crisis develops. That is not the future. Early versions of this technology are already being tested in hospitals in the United States and South Korea. Inside the operating room of 2035, the environment itself is intelligent. Walls embedded with sensors track sterility in real time. Cameras with machine vision monitor every instrument, every gloved hand, every surface. If a contamination risk appears, the system flags it instantly. No more guessing. No more relying purely on human observation. The room thinks. The room protects. The room acts. Let us talk about the cameras. The surgical robots of 2035 use imaging systems that go far beyond what the human eye can see. High-definition three-dimensional endoscopes project a magnified image of the surgical field that is clearer, sharper, and more detailed than anything a surgeon's naked eye could perceive. Surgeons literally see better through the robot than without it. And then there's fluorescence imaging, a technology that uses special light frequencies to make blood vessels glow. The robot can see arteries and veins in real time, in living tissue, in ways that were impossible just a decade ago. Cutting the wrong blood vessel is one of the most dangerous surgical errors. With fluorescence imaging, the robot sees every vessel clearly. Here is a pattern interrupt. Stop for 1 second. Think about your last visit to a hospital. The wait times, the chaos, the overworked nurses, the exhausted residents working 30-hour shifts. Now imagine a system that never sleeps, never panics, never makes a judgment call clouded by fatigue or emotion. That is what 2035 looks like, and it is almost here. The AI brain controlling the hospital of 2035 is not a single computer. It is a distributed network, part cloud, part on-site servers, part edge computing chips embedded directly into the surgical robots. Data flows continuously. Decisions are made in milliseconds. The AI is simultaneously monitoring surgical progress, patient vitals, equipment status, and environmental conditions all at once without missing a beat. One of the most powerful capabilities of the AI surgical system is something called autonomous task completion. This means a robot can perform certain defined, repetitive surgical steps entirely on its own, without a human guiding every motion. Closing a wound, tying sutures, removing tissue samples. The surgeon approves. The robot executes perfectly every single time. No hesitation, no variation. Now, let us zoom into the precision numbers. The Vinci surgical system, one of today's leading robotic platforms, already achieves sub-millimeter precision. The next generation systems being developed for 2035 are targeting nanoscale accuracy. We are talking about robots that can operate on individual cells. Microsurgery at a level that makes today's techniques look primitive by comparison. Speed matters too. Not reckless speed, but efficient, consistent speed. A robotic surgical system can sustain peak performance for hours without fatigue degradation. A human surgeon's precision drops measurably after the 3rd hour of a complex procedure. The robot performs hour 8 identically to hour 1. In long, complex surgeries, this difference alone saves lives every single day. The data control rooms inside the hospital of 2035 look more like NASA mission control than anything you would find in today's hospitals. Dozens of screens display patient data, robot status, surgical progress, and AI analytics simultaneously. A team of clinical data engineers monitors every variable in real time. This is surgery managed like a space mission. Nothing is left to chance. Smart sensors embedded throughout the robotic system continuously measure force, pressure, and resistance. When the robot touches tissue, it knows exactly how much force is applying. When it meets unexpected resistance, a scar, a calcified artery, an anomaly, it adjusts automatically. This sensory feedback loop is what engineers call haptic intelligence, and it is one of the most important breakthroughs in robotic surgery. But here's the question everyone is afraid to ask. What happens when the AI makes a mistake? Every system has failure modes. And in surgery, failure means death. The designers of the 2035 hospital know this, which is why every robotic system has multiple redundant fail-safe layers. If one component fails, a backup engages instantly, and a human surgeon is always present, always in control. This brings us to one of the most fascinating dynamics inside the hospital of 2035, the relationship between human surgeons and robotic systems. These surgeons are not replaced. They are elevated. They become conductors of a surgical orchestra. They make critical decisions. They handle the unexpected. The robot handles a mechanical execution. Together, they achieve what neither could accomplish alone. Training for these human-robot surgical teams is unlike anything in medical education today. Surgeons train using virtual reality simulation systems that replicate surgical procedures with absolute realism. They practice on digital patients, thousands of cases, before they ever touch a real person. The learning curve is compressed. The skill ceiling is raised. The error rate at graduation is almost zero. The robotic systems themselves also train continuously. Every surgery feeds new data into the AI. Every unusual case, every rare complication, every creative solution a surgeon invents, all of it becomes training material. The system grows smarter with each procedure. By 2035, the AI surgical brain will have processed more cases than any human doctor could experience in 1,000 lifetimes. Quality control inside this ecosystem is relentless. After every surgery, the robotic system runs a full self-diagnostic. Every motor is tested. Every sensor is calibrated. Every software process is verified. Maintenance issues are flagged before they become failures. The system predicts its own component wear and schedules service automatically. The hospital of 2035 is designed to be self-maintaining and self-improving simultaneously. Energy systems are a critical part of the equation too. The robotic hospital of 2035 runs on dedicated power infrastructure with zero tolerance for outages. Surgical robots require uninterrupted power, backup generators, battery arrays, redundant grid connections. Some facilities are being designed with on-site solar and hydrogen fuel cell systems to ensure the lights and the robots never stop, not for 1 second. Let's break down the AI software layer in more detail. The surgical AI of 2035 is built on deep learning architectures trained on medical imaging, surgical video, genomic data, and patient outcome records from around the world. It speaks the language of biology at a computational level that is genuinely breathtaking. It does not just assist surgery. It understands the human body at a systems level. Machine vision is the robot's primary sense. High-speed cameras capture the surgical field at thousands of frames per second. Computer vision algorithms identify tissues, classify structures, detect bleeding, and track instrument positions, all simultaneously, all in real time. The robot sees everything. It misses nothing. The AI processes what it sees faster than any human nerve signal could possibly travel. Natural language processing is also part of the 2035 hospital. Surgeons speak commands aloud during procedures. The AI listens, interprets, and acts. Increase camera magnification. Flag that tissue for biopsy. Switch to fluorescence mode. Voice control in the operating room eliminates the need to look away from the surgical field. The surgeon's eyes never leave the patient, not for an instant. Predictive maintenance algorithms monitor the mechanical health of every robotic component continuously. Vibration patterns, temperature data, motor current draw, bearing wear. The AI analyzes all of this in the background and predicts component failures days or weeks before they occur. Parts are ordered and replaced proactively. Downtime is minimized to near zero. The hospital operates like a perfectly tuned machine because it literally is one. Cybersecurity inside the hospital of 2035 is treated with the same seriousness as physical security. A hacked surgical robot is not just a data breach. It is a weapon. The AI systems are air-gapped during surgery. Communications are encrypted with military-grade protocols. Intrusion detection systems run continuously. Every command is authenticated. Every data packet is verified. Security is not an afterthought. It is architecture. Patient data inside the system flows through what engineers call a clinical digital twin. Every patient has a complete digital replica, a model built from their imaging scans, genetic profile, medical history, and real-time vitals. Before surgery begins, the AI rehearses a procedure on the digital twin. It stress tests different approaches. It anticipates complications. The actual surgery is performed after the simulation is perfected. This concept of surgical simulation before the real procedure represents one of the most profound shifts in medicine in human history. Today, surgeons plan on paper and in their minds. In 2035, they plan in a full three-dimensional virtual environment where they can literally practice the exact surgery on a perfect digital copy of the patient first. The result is a level of surgical certainty never before possible. Recovery is transformed too. Robotic surgery is minimally invasive by design. Smaller incisions, less tissue trauma, dramatically reduced blood loss. Patients in the robotic hospital of 2035 recover in days, not weeks. Hospital stays are shorter. Pain is reduced. Complication rates drop. The downstream economic impact of faster recovery is measured in hundreds of billions of dollars saved annually across the global healthcare system. Nanotechnology is beginning to enter this space as well. Researchers are developing microscopic robotic systems, nanobots, that could one day be injected into the bloodstream to perform internal repairs without any external incision at all. This is the horizon beyond the horizon. The robotic surgery of 2035 is extraordinary. But by 2050, the concept of cutting the body open at all may be obsolete. The scale of investment flowing into this space is almost incomprehensible. Venture capital firms have poured over $15 billion into surgical robotics companies in just the past 5 years. Major hospital networks are signing billion-dollar partnerships with technology companies. Governments are funding national surgical robotics programs. The economic engine behind the hospital of 2035 is massive, and it is accelerating every single month. Now for the questions that keep surgeons, economists, and ethicists awake at night. What happens to human surgical jobs? Today, there are over 1 million surgeons practicing worldwide. As robotic systems become more capable and more autonomous, the role of the human surgeon will inevitably change. Not disappear, but transform. Drastically. The surgeons of 2035 will be part engineer, part clinician, part AI supervisor. Hospitals in rural areas and developing nations stand to gain the most. Today, access to skilled surgeons is brutally unequal. A child in rural Kenya has almost no access to a specialist surgeon, but a robotic system guided remotely by a surgeon in London or New York changes everything. The hospital of 2035 could democratize surgical excellence across the entire planet. That is a genuinely revolutionary idea. The economic impact inside the United States is enormous. The American surgical robotics market is projected to exceed $40 billion by 2035. Thousands of high-skill engineering, programming, and clinical operations jobs are being created right now. This is not just a medical story. It is an American economic story. Surgical technology is becoming one of the most powerful new pillars of the innovation economy. The military applications are significant as well. The Pentagon has funded research into battlefield surgical robots that can stabilize wounded soldiers in combat zones without requiring trained surgical personnel on site. A robot that can perform emergency surgery in a field hospital or even aboard a ship or aircraft could save thousands of soldiers' lives in future conflicts. The stakes could not be higher. The ethical questions run deep. Who is responsible when a robotic surgeon makes a fatal error? The manufacturer? The hospital? The AI? The supervising physician? Legal frameworks around autonomous surgical systems are years behind the technology. Courts, regulators, and ethicists are scrambling to create governance structures for a world they barely understand yet. These conversations will define the boundaries of the 2035 hospital and beyond. There is also the question of consent. When a patient agrees to surgery, are they consenting to a robot performing it? Do they have the right to refuse robotic surgery? Should the standard of care evolve so that a robotic procedure, if demonstrably safer, becomes a default? These are not hypothetical questions. They are being debated in hospitals, courtrooms, and legislatures around the world right now. Here is the moment to pause and reflect. Every surgical robot being built today carries inside it a simple promise that a child born in 2030 will face a fundamentally different medical reality than the one we inhabit. That precision, access, and safety in surgery will no longer be privileges of wealth or geography. That the lottery of where you were born will matter less than ever as before. The hospital of 2035 is not just a building full of machines. It is the culmination of centuries of human ambition. From the first crude surgical tools of ancient Egypt to the nanometer-precise robotic arms of the coming decade, every generation of healers pushed the boundary of what was possible. The engineers, coders, and surgeons building this future are simply the latest in that long, extraordinary chain of human progress. And the story is far from finished. We are standing at the very beginning of the robotic surgical era. The breakthroughs happening in laboratories and operating rooms right now will seem primitive 20 years from today. The pace of progress is accelerating. The investments are compounding. The intelligence of these systems is growing exponentially. What comes next will make today's achievements look like the first flickering frames of film that has barely begun. This is a hospital of 2035. It is being built right now. It will change how we heal, how we live, and how long we survive on this planet. The question is not whether this future arrives. The question is whether you will be ready for it. If this documentary opened your mind, drop a comment below telling us what shocked you most. Subscribe to World Robot Factory because we are just getting started. The future does not wait.